Yes, sir.
Okay, if you have not done, then please check it from the solution that we have uh, solved. Or if you are having problem, then I can solve it again for you. Okay.
Okay.
So do I need to solve it again, or should I move to the next chapter?
Sir, I don't know is it the right answer or not.
Okay. So let me solve it for you once more time. We need to prove that. Stop. So if we need to prove this one, let me have to read this question. Okay, so here we have this, and it is being given that we need to prove triangle to prove triangle ABC congruent to triangle AB and then C congruent to triangle ADE. ADE to prove. The proof, we know that AB is equals to AD. AB is equals to AD given. Similarly, AC is equals to AE. It is also given to you. But the whole we have taken this triangle, but the angle only this is given to you. But we need this as a whole up to here. So and okay, and similarly in triangle this ADE, we have been given only this angle up to here, but we need this as a whole up to here. So this we need to, this is not added in both, only up to here it is given and up to here it is given. If we add both side this angle, then this will complete up to here and this will also complete up to here. So we need to write here, it is given that angle BAD, BAC, BAC, B then A then C, okay, BAC, no, BAC not a, BAD, BAD up to here, okay. So we have BAD is equals to, BAD is equals to EAC, angle EAC, okay, it is given. So we will add both side, adding angle this angle DAC to both side, DAC both side. And when you add both side this angle DAC, okay, equation, this is 1, this is 2, and this is 3, 2, third equation, okay. So we'll write angle BAD plus DAC is equals to angle EAC plus angle DAC. So when you are adding equals are added to equals, then it will also remain equal. Okay, so BAD, if we have BAD, okay, this BAD, and if we add BAD, and if we add this to this one, so this will become as a whole, this one, BAC. So this 2 when added to angle BAC is equals to, similarly in this angle, if we add this one, okay, if in this one, okay, if we add if we add this one, then this will become as a whole this one. Okay, EAD, angle EAD. So if BAC is equals to EAD, BAC equals to EAD, then we will say that this is the fourth. So we have two sides equal and one angle equal. Then we can say that by we are from. So we can say that by side angle side, two sides, this side and angle whole. Similarly, okay, similarly in this triangle, this side and this as a whole angle. Okay, so we will say that by side angle side, triangle ABC congruent to triangle ADE. Therefore by CPCT, sorry, therefore we need to prove this one only. Okay,
Okay.
ADE. So what is the main thing here is that we need to add these two. This small part fraction of the is given to us and commons we are added here. Okay, we are adding here. So that's why it is equal. Okay, you understood?
Yes.
Yeah.
Should I move forward?
Yes, sir.
Okay.
So let's move further. Let's move further. If we let's start the quadrilaterals. Quadrilaterals. Okay. So if you are talking about the quadrilaters, then in quadrilaters, what are quadrilaters? We will say that a closed.
It's a polygon with four sides.
A closed four side figure is called a quadrilateral. Okay.
Yes,
so if we have this like this shape, this is also quadrilateral. This is also a quadrilateral. This is also quadrilateral. This is also a quadrilateral. This is also a quadrilateral. Okay, this is also a quadrilateral. So these are all quadrilaters. Okay, understood?
Yeah.
So these
Yeah.
four sides, if they are close together, then they form quadrilaters. Now that they are different types of quadrilaters. Okay, one is trapezium. Okay, then after the trapezium, we have parallelogram. Okay, then after parallelogram, we have what we have.
Rhombus.
We have yes, rhombus. We can say that parallelograms are of different types.
Square is
Rhombus,
there. Rectangle is also there.
rhombus, then rectangle. Okay, rhombus and rectangle. Okay, we have rhombus and rectangle and square. Okay.
Yes, sir.
The same chapter was in 8th class, I guess.
Yes. Okay. So let's start studying this one. So if I'm talking about this one quadrilateral, okay. So what is trapeziums? If you say that all square are also trapezium, all rectangle are also trapezium, means from bottom to top it is correct. Okay, all square are trapezium, all rectangles are trapeziums, all rhombus are trapezium. Okay, similarly all rectangles are parallelograms, all rectangles are trapezium also. Similarly all parallelograms are trapezium. You understood? But If we come back like this, all trapeziums are parallelogram? No.
No, yeah,
All
yeah.
all parallelograms are rectangle? No. All parallelograms are square?
Okay.
No. But if we take all squares are parallelogram? Yes. All squares are trapezium? Yes. Why? Because the minimum criteria is satisfied by them. If we say
Yeah,
that
yeah.
opposites, only opposite two sides are parallel. Opposite two sides are parallel. So if any quadrilateral is going to have opposite two sides parallel, then it is a parallel, it is a trapezium. So square also have opposite two side parallel, rectangle also has opposite two side parallel, rhombus also have opposite two side parallel. All parallelograms are going to have opposite two sides parallel. So we'll say that all parallelograms, either whether it is rectangle, rhombus, and square, they are all trapezium. Okay, understood?
Yes, sir.
Yeah, yeah,
Uh,
understood.
opposite two only. Any, or we can say any two opposite sides are parallel. Any opposite any two sides. We write here any two sides are parallel, not opposites. Okay, and here we will have the two opposite sides. Opposite sides are parallel. So if in quadrilaters, if the opposite sides are parallel, then it is a parallelogram. Okay.
Yes,
Okay.
sir.
Okay. If any two opposite sides are parallel, then it is a parallelogram. Rhombus, opposites two sides are parallel as well as all sides are equal. Opposite sides are parallel. Okay, are parallel, and all four sides are equal. If all four sides are equal and parallel, four sides are parallel, then it is a rhombus. Okay,
Yes,
Okay.
sir.
and in rectangle, in rectangles, all opposite sides are parallel. Opposite sides are parallel. Okay, and any and vertex angles is 90 degree, and vertex angle is 90 degree. Okay, I'm writing 90 degree. Okay, and here opposite sides are parallel. Okay, all four sides are equal, and vertex angle, it means corner angle. Okay, vertex angle is 90 degree. Okay, now talking about their diagonals. If we talk about their diagonals, then okay, then we need to write here about the diagonals. So trapezium don't have equal diagonals. Means it may have or may not have. Okay, so we are not talking about the diagonals. If we are going to sure, means it may have or it may not have the opposite. For example, if we are having like this, this diagonal is not equal to this diagonal. Okay, but if we
Yes,
have
sir.
the two okay, but if we have this one, so it may have the two diagonals equal. If we have this side is also equal to this side, and it may have equal diagonals. So we are just writing on the diagonal property, which is 100% will be there. Okay, it may have or it may not have. This is not so. If it have, then we have to write. Okay. So for example, if I'm talking about parallelograms, so diagonals are not equal. So so we'll surely say that. But rectangle is also a parallelogram. So it has equal diagonals. Okay. So we are not writing about this one. Parallelograms may also have equal diagonals or may not have equal diagonals. Okay. In squares and rectangle, there is equal diagonals, but in rhombus we don't have, and in normal parallelograms like this, we don't have equal diagonals. Okay. This diagonal is big and this diagonal is small. So here we are going to have rectangle, that if we are need to have a rectangle, then it must have equal diagonals. Okay, so if there is a parallelogram which has equal diagonal, then it is a rectangle. Okay. Any
Yes, sir.
parallelogram which has equal diagonals, then it is a rectangle. Similarly, if we have a square can be like this. The square is like this, but it must have equal diagonals, and they must bisect at 90 degree. At 90 degree means in a square, the diagonal bisect each other at 90 degree. Okay. If otherwise, if there is no if they are not bisecting, then so it must have equal diagonals, and here it only have equal diagonals. It's not necessary condition that it must bisect at each other at 90. For example, this is a rectangle. So they have equal diagonals. If A, B, C, D, so AC is equals to BD, but this angle is greater than 90 and this is less than 90. So, but if we're talking about this square, and in a square, it must have equal diagonals. Okay.
Yes.
As well as they must bisect. Similarly, here the condition for equal diagonals only, here the condition for equal and 90, and here is the condition for 90 only. In rhombus, diagonal bisect each other at 90 degree. This is must. Diagonal must bisect each other at 90 degree. Okay.
Okay.
Here the condition is not for equal diagonals, but here the condition for equal diagonals, but not for 90. Here in the square, both the conditions are there. It must bisect equal diagonal, it must have equal diagonal, and it must have bisect at 90 degree. Here is only for bisecting condition, here is only for equal condition, but in a square, it has a condition for both equal as well as 90 degree. Okay, so please note it down.
I noted down, sir, everything.
You noted everything, Alvina? Have you noted or
Yeah.
still writing?
Yes, sir. Noted.
Noted. Let's talk about this one. So,
We're so tired. You're so tired, right?
I'm so tired.
Yeah.
No, who's saying? I'm just having a little bit, you can say that when the climatic conditions are changing in India, and last night I slept using means having an AC turn on, and due to that I'm just feeling a little bit cold. Okay, that's why I've taken the medicine, but I'm fine. Okay. You're saying I'm just a little bit tired. Okay, just coming back with much energy. Okay, Rima, just feeling I'm just feeling tired. No, Rima. Okay, coming back to the point here. So, what is the minimum condition to prove a parallelogram? Minimum condition. The parallelogram must have opposite two sides parallel. If we have any quadrilaters where opposite two sides are parallel, okay, only then it is a parallelogram. If we have proved that opposite two sides are equal, then it is also parallelogram. And if we have, like for example, like if I'm having any quadrilateral, if we have proved that if to minimum condition to prove a parallelogram. Okay. Opposite first condition. Prove opposite two side parallel. Opposite two sides parallel. Okay. For example, if we have proved this is ABCD is a quadrilateral, and in ABCD quadrilateral, if we have proved AB parallel to DC and AD parallel to BC, then it will be proved that it is a then ABCD must be parallelogram. Okay, you understood?
Yeah.
And instead of using opposite two sides, if we have proved that, second is prove opposite sides are equal only. Opposite sides are equal only. Okay, means if you proved AB is equals to DC and AD is equals to BC only. Just prove this one. Okay.
Okay.
Then this is sufficient to prove. Then we can say ABCD is parallelogram. Okay. Or if you have proved here AB parallel to DC, and sorry, here also we have to write parallel sign, and AD parallel to BC. Okay, means opposite sides parallel proof, or opposite side you are proving equal. Okay, then it will be a parallelogram. Now the third condition is prove, take any two sides and prove them parallel as well as equal. Take any two sides, prove any two sides. The third one is prove any two sides parallel and equal, both. Okay, for example, if you are having this ABCD as a parallelogram, as a quadrilateral ABCD, and you have proved that if you have proved that AB is parallel to DC and the same side AB parallel to DC you have proved, and you have also proved that AB is also equals to DC, then this is sufficient that ABCD is a parallelogram. So what conditions that you have to either prove out of three? If you have chosen any one, then ABCD will be proved as a parallelogram. Okay, understood? So what are the yes? So if you have proved, I'm just going to explain the basic of the quadrilateral that you will do. Either prove what we have chosen. First case, either prove AB equal to DC and AD equal to AB parallel to DC and AD parallel to BC. Either prove this side parallel to this side and this side parallel to this side. Then ABCD will be a rhombus. Okay. Okay. Second
Okay,
case,
sir.
either prove
Sir, do we need to
AB.
specifically write with what shape is it
Yes,
that this
because
is a
we need,
rhombus?
no.
Therefore, it is a parallelogram.
Yeah, therefore it is a parallelogram. Okay, because all parallelograms are means rectangle is also a parallelogram, square is also a parallelogram. Okay, so then we will go basic further about that. For example, if we have proved parallelogram, now if we have to prove this parallelogram as a rectangle, that when what minimum condition we need to prove. Okay. Okay.
Okay.
So first of all, we are just taking that if you are having a quadrilateral, then what are the minimum condition that you need to prove for proving a quadrilateral to be as a parallelogram? So if we have either proved AB parallel to DC, okay, and if we have proved AD parallel to BC, okay. The second thing is if we have proved AB parallel to DC and this side parallel to this side, or prove AB, don't prove parallel now, prove equal. AB equal to DC and AD this side equal to this side, means just prove instead of proving parallel, okay, then prove AB equal to DC and AD equal to BC. Okay, AD equal to BC. Okay, and the fourth case, if you are not just choosing the opposite two sides, then select any two sides. Just prove that this side is parallel to this side. First prove AB parallel to DC. And the second case is prove also that AB is also equals to DC. AB is also equals to DC. So if you have two sides and the same two sides are parallel as well as equal, then it is a parallelogram. If we have the opposite sides equal only, this side is equals to this side and this side is equals to this side, then it will be a parallelogram. And if we have proved this side parallel to this side and this side parallel to this side, don't prove them equal, they will automatically become equal. Okay, understood?
Okay.
So this are the three criteria that how can you prove a parallelogram, a quadrilateral into parallelograms. Okay, so have you noted this one? If
Just
you
a
have
second.
note it fast.
Yeah.
Alvina, you also?
Done, sir.
Done. Okay, do this one also.
I'm done, sir. I'm already done.
Okay.
Finish, sir.
Okay. Now moving to the next part. For example, if you are going to have now how to prove parallelogram. If you have proved the quadrilateral as parallelogram, okay, parallelogram. Then if you need to prove this as a rectangle, prove a parallelogram as a rectangle, prove a parallelograms as a rhombus, okay, and prove a parallelogram as a square. Okay. So if in a parallelogram, first point, you have already proved, you have ABCD as ABCD as parallelogram, you have proved this one. To prove any angle is 90 degree, then if that parallelogram will become rectangle. Okay. Okay.
Sir, sorry, can you repeat it?
Yes. If you are having that ABCD is a parallelogram, you have proved that ABCD is a parallelograms. Okay.
Okay.
Then just prove, and you need to prove that first you need to given that, let's suppose you have been given that ABCD is a quadrilateral. Okay, ABCD is a quadrilateral, and which type of quadrilateral it is rhombus or parallelograms or whatever it is, you have not been given. So you proved according to the given conditions in the questions, you have proved that ABCD is a parallelogram. Okay.
Okay.
Now further, the question is not asking you to prove it ABCD is parallelogram. The first step is just to prove this one as parallelogram. Question is asking prove ABCD is a rectangle. Don't prove it as parallelogram. So first step is just you need to prove it as parallelogram. And now the next step you will first step is this one. For example, if you went to the if you are just making a cup of tea for you,
Okay.
the first step is just you will add all the ingredients and okay, to that one, and then you will take the tea into the cup. Okay. So
Yeah.
similar step is that if you are going to prove anything, because this and this all are parallelograms, the square, rhombus and rectangles are parallelograms. So if it is being asked to prove ABCD as a rectangle, so first prove it ABCD as parallelogram, and then after that prove one of any angle as 90 degree. So if you prove any angle 90 degree, then it will be automatically become a rectangle. Okay.
Okay.
So either prove that means first case, first step, either is any one of them. If you are just proving, I'm just writing points. Prove any vertex angle 90 degree, any vertex angle as 90 degree. It may be given that angle A is 90 degree. If you have proved ABCD is a parallelogram, and it may be given that angle A is equal to 90 degrees. So you can simply write that if in a parallelogram any one angle, any vertex angle is 90 degrees, then it is a rectangle. So it may be given or you may need to prove. Okay.
Okay.
The second thing is don't prove 90 degree, prove diagonals are equal. Diagonals are equal. If you have proved diagonals are equal, then it will become automatically okay. Just prove that diagonals are equal. Okay. So if you prove diagonals are equal, so in a parallelograms, if there is diagonals are equal, then it is a rectangle. Okay.
Okay.
Okay. So these are the condition to prove a parallelogram to the rectangle. Okay. So next one is, if you have a parallelograms, ABCD is a parallelogram. Okay.
Yes, sir.
And you need to prove that as a rhombus. So so you can't prove it's 90 degree because all rhombus is like this. So it don't have 90-degree angle. So you need to prove they don't have equal diagonal. So what is the minimum condition that you need to? So then you need to prove that their diagonal bisect each other at 90 degrees. So this is the only condition if you need to prove, or either prove all sides are equal. Prove all sides are equal. Either you can prove all sides are equal. If in a parallelograms all sides are equal, let you prove this side is equal to this side and this side is equal to this side. It will be given because it is parallelogram. Because ABCD is a parallelogram, you have proved that opposite sides are equal. But if you prove that AB is also equals to AD, prove our side is equal or any two adjacent sides equal. Adjacent means this side is equal to this side, or this side or this side. Opposite side are this and this. And this and this. Okay, these are the opposite side. Adjacent sides are AB and AB and AD. Adjacent side
Okay.
this and this. Okay, to prove, or you can say prove any two adjacent side equal. Prove all sides are equal, i.e. any two adjacent sides equal. Any two adjacent side equal. Any two adjacent side equal. So if you have proved that the ABCD is a parallelogram, you have proved that ABCD is a parallelogram, and in that parallelogram you have also proved that AD is equals to DC. This side is equals to this side, then it will automatically become rhombus. Okay.
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 The next one is prove either you can take this way or prove diagonals bisecting angle at 90 degree. Diagonal bisect at 90 degree. So if you have proved that diagonal bisect at 90 degree, then it will automatically become rhombus. Okay.
Okay.
So because, okay, next one is for a square, what you need to prove? Prove all side equal and equal diagonals You can prove this one. Prove all side equal and vertex angle 90 degree and vertex angle 90 degree. If any in a parallelogram, if all sides are equal and any one of the angle is 90 degree, then it is a square. Okay. Okay.
Okay.
So either you can prove all side equal and diagonals equal. Okay. Either you can prove all side equal or vertex angle equal. Vertex angle as 90 degree. Or even you can prove equal diagonals. Choose this one and this one. Okay. Equal diagonals and vertex angle 90 degree. Okay, so you can prove this. So this will be automatically become. Okay, done. Note it down.
Yeah.
Then we shall. Note it down. When you're done, please let me know.
Yes, I'm done.
You're done.
Yeah.
Done,
Okay, so
sir.
let also. So let us start. Let's have this question. Draw this figure. Let's check whether first start with this easy one. Do question number one. Note down the question number one. If the diagonal of parallelograms are equal, then it is a rectangle. You need to prove that it is a rectangle. That we have also written that there's three conditions by which we can prove a parallelogram as a rectangle. One is prove vertex angle 90°, prove diagonals equal. Okay. So we need to prove this one. So do question number one and note it down. If the diagonals of parallelograms are equal, then show that it is a rectangle.
Okay.
Noted, sir.
Noted, everybody in the class?
So just a second, I will.
Okay, take your time. Rima, honestly tell me, do you think that you are learning something here?
Yes, it's more helpful for me than school.
Okay, that's why I'm just asking that.
Yes, I wrote the question, sir.
You also, Alvina, noted? Yes, you have already
Yes.
noted. So what is being given to you? Prove that the diagonals of if it is being given to you that ABCD is the parallelograms and its diagonals are equal, then it is a rectangle. You need to prove it is a rectangle. So proof. So what we need to prove here is we need diagonals are given there, equal diagonals are given. Just prove 90°, any angle 190°. Okay, then it will be a rectangle. Okay, understood?
Okay.
So what we
Yes,
need to
sir.
do here is we have been given that ABCD is a parallelogram. And it is, if it is being asked to prove rectangle, then try to make the shape as rectangle. Whatever being asked to prove, try to make the same shape. Okay.
Okay.
So it is being given to you that ABCD is parallelogram. Okay. And it is also being given that the diagonals are equal. This is equal to this. Okay. So you can make it, draw it like this way. So it is also given AC is equals to BD. Okay, how can you prove that this is a rectangle? Just you need to prove any one angle as 90°. How can you prove this angle as 90°? So how will you prove? You know that in a parallelogram, since this side is parallel to this side, okay, this side is parallel to this side. So this angle, if this side is parallel to this side, so the sum of this angle and this angle will be 180°. Like this, we have studied in the early lines and angles. If these the sum of adjacent interior angle is 180°. Okay, so this the sum of this one and this one should be 180°. Okay, 180°. Okay, and if it is suppose if it is 120°, then this will be 60°. Okay, if it is 130°, then this will be 50°. But if I'm saying that this and this are equal, so if they are equal, then it will be 90 and 90 only. Okay, 90 90, because 90 90 will gives you it will be equal also, the sum will also 180°. Okay, otherwise we need to keep both. Okay, if it is x, it is x, then x plus x should be equals to 180°. So 2x is equals to 180°. Then you cut it, you will get x is equals to 90°. Okay. Similarly, if this side is parallel to this side, so this angle should be equal to this angle. Okay. Okay. These two are going to, if we have these two lines. Okay. So this angle should be equal to this angle. Okay, similarly, this angle should be equal to, means the sum of these two interior angles should be 180 degrees. So let me explain you that how can you prove this one. So take this triangle. Take this triangle, the red one. Okay, again, we are just going to study congruency in this one. And the blue one. Okay. So what you are going to take here in triangle. Okay. In triangle ADC and triangle. If we have taken ADC, then the name of other triangle will be? The name of other blue triangle will be BDC or BDC or CDB. What should be its name? Tell me, we don't have all day.
Sir, BCD, triangle BCD.
It would be triangle BCD. Okay. Now, if you know that AD is equals to BC, why it is being given? It is given because ABCD is a parallelogram, and in parallelogram opposite sides are equal.
Yes, sir.
And DC is equals to DC, common. And diagonals are also given to you. Diagonals is also given, that AC diagonal of red triangle is equals to BD diagonal of blue triangle. Okay. BD diagonals of blue triangle. It is also given. So by side triangle, the three sides we have taken. Triangle ADC congruent to triangle BCD. Therefore, by CPCT, we can say that angle D or ADC, angle ADC will be equals to angle BCD. Okay. This angle of red will become equal to this. Or you can simply write angle D is equals to angle C of blue. Okay. Angle D of red, because you have taken that red triangle is congruent to blue. So this angle of red will be equal to this angle of blue. Okay.
Sir, actually, I'm not clear.
You're not getting? Alvina, are you getting this one?
No,
Alvina,
sir, I didn't understand.
you have to prove this red and blue triangles congruent triangles. Okay, you have taken this ADC. Let me show you here the red one, ADC, and this one. This is ADC, and this one BCD. Okay, so this side is equals to this side. Why? Because ABCD is a parallelogram, so opposite sides are equal.